Machine Readable Cataloging, MARC. BIBFRAME is intended to replace MARC as the encoding and exchange format for the bibliographic data produced by the library community. But why? What is it about MARC's design that requires the format to be replaced? First of all, the design of MARC can perhaps be best understood as an exchange format which emphasizes the display of bibliographic information about specific library holdings within electronic catalogs. As a result of this emphasis, MARC records can be conceived as aggregates of information that include descriptions of both the conceptual essence of resources as well as aspects of their physicality. These aggregates are realized in the cataloging process through the application of content standards such as URI2 and now RDA, and are captured, for the most part, in a series of tagged literals or tagged text strings. Ultimately, the overarching structure of MARC records and the content rules used to realize them serve as means to display bibliographic data in much the same way as the physical card catalogs which were its predecessor. MARC's design has served the library community well over the years and has, as the Library of Congress points out in their introductory paper on the BIBFRAME model, allowed librarians to accomplish three important bibliographic tasks. To capture information about the intellectual essence of resources. To capture information on the physical aspects of resources. To capture information about the management of resources such as control numbers and record handling codes. To capture information about the intellectual essence of resources. To capture information on the physical aspects of resources. To capture information about the management of resources such as control numbers and record handling codes. However, within the current context of the web environment coupled with the increased processing capabilities of modern computers and applications, MARC's design presents the library community with a number of structural difficulties that limit the potential uses of bibliographic data. First of all, MARC's reliance on the use of literals as identifiers for resources and the elements that compose bibliographic records limits the ability of machines to process MARC information. As a result, variations or equivalences of literals are difficult for machines to parse. Secondly, MARC does not separate information regarding the intellectual content of a resource and its physical carrier clearly enough. Even with adjustments to MARC, such as those included in RDA, an FRBR-based content standard that makes a clearer distinction between the content and carrier, the very format of MARC will not allow machines to utilize it fully. Thirdly, the structure of MARC records, although information-rich, are poor at expressing relationships between bibliographic elements in ways that machines can easily understand. Again, even with adjustments to MARC, such as MARC/XML, a serialization intended to increase the machine readability of MARC records, the use of content standards like URI2 which were developed primarily with display issues in mind prevents the processing of MARC data significantly. Ultimately, this means that library data is unable to interact with the vast majority of computer applications automatically, limiting the exposure of bibliographic data on the web, preventing the rich relationships between data elements from being realized and effectively hiding bibliographic information from online users. BIBFRAME is designed to address these issues. To begin, as one researcher notes, BIBFRAME is not only designed to replace MARC as an encoding and exchange format but to offer a complete reconception of bibliographic description itself, one that is in line with the capabilities of the web environment. BIBFRAME accomplishes this in a number of ways. First, BIBFRAME replaces the idea of the catalog record with the notion that a resource is defined by a discrete series of bibliographic elements. These elements clearly distinguish between the intellectual content of a resource, its physical carrier, and the various entities responsible for its production. Freed from the record as a bundle of data elements, the individual elements are better able to interact in computer applications, and the cataloger is better able to describe relationships between elements. Secondly, text strings or literals are replaced by URIs or universal resource identifiers. By using URIs to identify bibliographic elements and their values, machines are better able to process the bibliographic information and to utilize the relationships described between them. These two elements, when built upon a web-based architecture and serialized in RDF/XML, permit BIBFRAME bibliographic data to interact more freely on the web. However, despite these changes and the claim that it is standard agnostic, the BIBFRAME initiative also claims that BIBFRAME will be backwards compatible with MARC, meaning that MARC will be mapped to BIBFRAME in such a way that MARC data can be automatically converted to BIBFRAME data without loss of information. Indeed, the BIBFRAME initiative has already developed tools that are available on its website which can translate MARC data into BIBFRAME 2.0. As the relationship between MARC elements and BIBFRAME entities may be complex, may even be many-to-many, as one researcher notes, the success of such a mapping remains to be seen. Screenshot of the BIBFRAME comparison service results page showing MARC data, left, and BIBFRAME RDF/XML data, right, for Terry Flanagan's Snoopy on Wheels.